In this set of videos, we're going to talk about surface area of 4 different shapes: so a prism, cylinder, prism, and a cone. So we're going to first do a lot of definitions, which is why I printed out the page for you. And don't forget to make sure you fill out all the different pieces on the lines, as well as filling out the last 4 questions when we're actually working out the surface area. So the first one is a prism, and a prism is when we have it's a polyhedron with 2 congruent faces, and those faces are called the bases. So if you look at our picture over here on the right, the bases are these parts in red, so you can't really see the bottom one, but it's a hexagon. And we label it again by the shapes. This would be a hexagonal prism. There are different types of faces, and one is called the lateral faces. So it's basically everything except the bases. We've already talked about edges, but the lateral edges are just the segments connecting those vertices together. So if you're looking at our picture over here on the far right, they're the ones that are going up and down, so not the ones that make the base, but the other ones, so the ones that are connecting the bases together. The surface area is when we take the sum of all of its faces. So that means all of the flat edges, so that means also the bases. The lateral area then is when we just take the sum of the lateral faces. So if you look over in blue, that is the parts in blue, so it's not the bases. A net, you've probably seen a net before, but what it is it's a 2-dimensional representation of the faces. So in this first one is when this is the net, and this is our 3D This is in 3D, and this one on the left is in 2D. So the one on the left is the net of that prism. So sometimes you might see a picture written that way, but you just have to realize that that's the net where it's opened all up. This slide is mostly just showing what a right and oblique prism is. So we're going to see this in different shapes as well, but oblique prism just means that it's not straight up and down, so it's not perpendicular with the base, but the height of it is still comparable between the two of them, and we're still going to use the same formulas when we're solving these. All right, so now we're going to talk about a cylinder and a pyramid. So we've got a couple different pictures on here. A cylinder is a solid with congruent circular bases. So if you look over on the far right, our circular bases are the parts in red again. We can't see them but on the bottom, but we can see the top one. And there are 2 of them, and they are parallel to each other. So make sure you take note of that. The height then is it's perpendicular between the bases, so it's straight up and down. So if you're looking at the oblique cylinder right here, it still needs to be perpendicular between the bases. So it may not be connecting the centers together, but it will be perpendicular to the bases. For a pyramid, we have over here on the right, it's a polyhedron in which the base is a polygon, and the lateral faces are triangles. With a common vertex. So if you look at the far right, you can see this. So the vertex is up here at the top, and then our lateral edges are the ones that connect the base to the vertex. The vertex does not necessarily need to be straight up above it, but if it is right in the center of our base, then it's called a regular pyramid, as long as the base is also a regular polygon. So for a regular pyramid, the base is a regular polygon. So like a square, not a rectangle. And the height of the pyramid is perpendicular to the base. The slant height, this is one you got to pay attention to, is it's slanted, as you can tell, but it is the height of one of the triangles in your pyramid. So it's not the lateral edge like we see up here. It's right down the center of that triangle. So sometimes you might have to use Pythagorean theorem to find that slant height. A cone is going to have similar characteristics as some of these others. So a cone has a circular base, just like a cylinder, and a vertex that's not on the same plane. So it's kind of like the pyramid, where it's just up in the air above it, but it is just not on the same plane. Next is our slant height. The distance between the vertex and a point on the base edge. So if you remember from our pyramid, it was the height of the triangle along the edge. We don't really have a lateral edge on a cone just because it is circular around it, so around the outside of it. So it's really just the slanted part. So a cone's a little more obvious of where the slant height is going to be. So that's my little L right there. Then the lateral surface is everything except the base. So all segments that connect the vertex with points on the base's edge, and remember it's everything except the base. A right and oblique cone, if you can tell by my picture, remember the oblique is just kind of at a slanted, but the height needs to be still perpendicular to the base, so straight up and down. And same thing here is straight up and down when we're finding the height. On here, there's nothing really specifically to write other than just to underline some different things. So if you notice, there is a capital B in some of these equations. The capital B all stands for the area of the base. You have to think of what the shape is of the base and then to find the area of that. If there is a capital P, we still have perimeter of our base, so around the outsides of it. And let's see, we have H in a couple of these. We have the height of the prism, so that has to be the distance between the bases, so don't forget that. And that is the same for our cylinder, that H is going to be the height of the cylinder or the distance between the bases. Next we have the radius, and those show up in our cylinder and in the cone, but that's because the base itself is a circle. And then lastly is the slant height. And the slant height, remember, is the height of the side, so not straight up and down, but it is the slanted edge along the side of our shape. So with our pyramid, it is perpendicular to the center of the base of those triangles, and in the cone, it is just the slanted diagonal, or it's like the hypotenuse, there we go, the hypotenuse of your triangle that's created with your cone. So what you need to focus on these is it's going to be set up the same way on your worksheets when you do this in class. And you're going to have to first name the figure, the shape of the base, and then find the lateral surface area separate from the total surface area so you can see how they relate to each other. So we've got one of each of them. First we have a prism, and the reason I know it's a prism is because I have two bases and it is perpendicular to each of them, and the base is not a circle, otherwise that would be a cylinder. So the name of my figure is a triangular prism. Remember, we name it based on the shape of the base, so my base itself is the triangle. Next, the shape of the base is a triangle. Lateral surface area, if you remember with your prism, is going to be the first part of the equation. So that means that it's just the capital P times the H, and that's it. My total surface area then is going to be the lateral plus my two bases, so my area of my two bases. All right, so our perimeter, we're just going to start listing out the different pieces we need to find. So the perimeter of my base, so I have to add the 2 plus 2.5 plus 1.5 together. And that gives us, let's see, we get 6. So that's my perimeter. And then times the height. Remember, the height is not the height of the triangle, it's the height of the prism. So it's the distance between the two bases. So that would be my 10 is my height. All right, so when I multiply that, I get 60, and this is meters, so meters squared. Then with the total surface area, we're taking that same answer, so 60 plus, and now 2 times the area of my base. Now realize that the base itself is a triangle, so we have 1/2 little b times little h, so we're talking about just the triangle now, so the base of the triangle is 1.5, the height of the triangle is 2. So my capital B itself comes out at 1.5, so I'm going to take 1.5 times my 2, add 60 to it, and I get 63 meters squared for the total surface area. So really the bases are the smallest portion on this, because really the bases themselves is only 3 square meters, and that's it. The rest of it is the lateral surface area. All right, so going on to the cylinder, we can see it's a cylinder. Think of a Coke can. And the base is a circle. For the lateral surface area, or is just the first part of our equation, so 2 pi r h. My total surface area then is that again, plus the area of my bases. So the different letters that we need to use is the R, so my radius, the height of my cylinder, and that's it. So my radius in this picture is 2, so the radius of the circle. The height of the prism, or not the prism, the cylinder, sorry, is again the distance between the bases, just like a prism. So it is 5. So let's go ahead and plug all of our numbers in. So 2 times pi times the radius times the height. And I want you to first start writing it in with the pi symbol with it. So 5 times 2 is 20. So this is 20 times pi. And then when I type that in the calculator, I get 62.832, and this would be centimeters squared. For the total surface area, I'm taking that answer, and I'm adding 2 pi r squared to it because I've got 2 bases. So remember, the first one was really 20 pi, and when I take 2 squared and then multiply by 2, I get 8, so I have 8 pi. So together we have 28 pi, and now go ahead and type that in the calculator, and we end up with 87.965. And this would also be with centimeters squared. So on to the last 2 shapes. We have a pyramid and a cone, and the way we can tell the difference between them is by the shape of the base. So pyramid is basically the same thing, except it is a square or a rectangle on the bottom, but here, if you notice, the sides on the edges is a square. So this would be a square pyramid. So the base is a square, since all 4 sides are the same. And for the cone down below, the reason we know it's a cone is because the base is a circle instead. And we just say it's a cone because all the bases of cones are going to be circles, so we don't change the first word. All right, so going back up to our pyramid lateral surface area, remember, is just the first half of our equation. So 1/2 P times L. The total surface area then, we start with the same piece, because that's really the lateral surface area. And in a pyramid, we only have 1 base, so it's just plus B. For our cone, our lateral surface area is going to be pi r L. Total surface area, and it starts with the same thing, so pi r L. Plus, and it's just the area of the circle, so pi r squared. And there's only 1 circle, so that's why there's not a 2 in front of it. So when we plug in our numbers for the pyramid, we have a capital P, which is the perimeter of our base. So remember, we have 25 is each of the sides, and there's 4 sides to it. So our perimeter is 100. The slant height is the height of that side, so not the edge, but in the center of that triangle, so 32. And we still have a capital B we have to find, so the area of the base, so 25 times 25, and we get 625. So let's plug all of our numbers in. So we have 1/2 times the perimeter, so 100, times the slant height, which is 32. When we multiply that all together, we get 1,600, and this is feet squared. For the total surface area, we have to take that number and now add it to the area of our base, which is 625. So when we add those together, we get 2,225 feet squared for the total surface area. All right, for our cone, we have an R we need to find and an L. So a radius is our 6. The slant height is 10, but remember, you might have to use Pythagorean theorem at some point sometimes to find that slant height. So in this one we don't, but you could. So let's go ahead and plug all of our numbers in. So we have pi times the radius times our slant height, which is 10. So we get 60 pi, which when we type that in the calculator, we get 188.496, and this would be inches squared. So we need to use that answer, so 188.496, and now we have to add the area of our circle, so pi r squared. So remember, this was really 60 pi plus, we get 36 pi there. So if we add those two together, let's see, we end up with 96 pi. So if you multiply 96 and pi together, we get 301.593, and this should be inches squared. So don't forget to put your inches squared or any of your units with your corresponding figure on any of the pictures you do.